Good evening, everyone. I hope you're all doing great and ready for an exciting session today. So, I would like to introduce myself. I am Harshada, the anchor of today's webinar. On behalf of K.K.WAGH Institute of Engineering, Education and Research, NASIK, and the IET NASHIK local network, I'm delighted to welcome all of you to webinar 2 of the IET K.K.WAGH EXPO, Working Model Contest 2026. Many of you already know that but for our new participants, this expo was formerly known as the IET Karmavir Expo, and it proudly carries a 23-year-old legacy of inspiring engineers, innovators, and problem solvers across the nation. Today's session is special because we are diving into a topic that sounds mysterious, powerful, and sometimes even scary: artificial intelligence. The title of today's webinar is AI From Breaking to Building the Black Box. We are going to decode what's inside this black box, understand how AI models actually work, explore how AI and IoT come together, and learn how real innovation starts with smart planning. And to take us through this fascinating journey, we have an extraordinary guest with us today. Ladies and gentlemen, allow me to introduce someone who truly embodies the spirit of modern engineering, Mr. Vimal Chaubey, sir. He is the chairperson of the IET Mumbai local network and currently works as a principal engineer R&D tech at GSK. What makes him truly inspiring is not just his technical expertise, but his belief in engineering is democratized technology. He is passionate about fitness, entrepreneurship, and yes, he is also a dedicated marathon runner. He contributes actively to the data and AI working group of the IET Future Tech Panel, shaping how future technologies evolve. And here's something we all are proud of. He is the recipient of the prestigious Paul Fletcher Medal UK 2024, awarded for the excellence and leadership in engineering. We are extremely fortunate to have him guide us today. So, without further delay, I request Mr. Vimal Chaubey, sir, to take over the session and unlock the fascinating world of artificial intelligence for us. This is just an instruction for all. If you guys have any questions through the ongoing session, you can drop it into the chat box. The questions will be addressed at the end of the webinar. This is an instruction, again, that the certificate will be provided to people who have attended the webinar for minimum 45 minutes. For that, we will share a link of feedback form. Don't miss to fill out the feedback form or you'll miss your certificate. Thank you. Sir, the virtual stage is all yours.
Thank you, Arshada, for this nice introduction. Before I start, I would like to thank K.K.WAGH Institute of Engineering Education and Research for giving me this opportunity to share my learning and experience with all of you. Thank you, Munji sir, for all the coordination efforts and bringing this opportunity to me. And thank you all of you who are going to spend next 1 hour with me. And I hope you will learn something which you can implement in real world with the uh, with the you can implement with this you can implement today's learning in your project, and you can create something interesting which will be helpful for the world. Now, there are two most fundamental rules for these sessions. No answers, no worries. If I ask any questions to you or you are asking any questions to me and I am not able to answer in case, that's perfectly fine. I will share my answer via Manjay sir and he will convey that further to you. Second thing, if you feel that any answer is wrong, better to express that. It's better to have a wrong answer than no answer so that we can identify where are we wrong and then we can improve ourselves and we can go in right direction. So this is one yeah. So this is one article which I read that Sachin Tendulkar helped me read every variation of RS on debut recalls Richard Levy. Richard Levy was uh, having his debut match. He's from South Africa, and in 2012 in debut match he scored 50 runs and he got man of the match prize. And in 2020 he expressed that Sachin Tendulkar was able to Sachin Tendulkar helped him so that he was able to understand R. Ashwin's variation, and then he played well against R. Ashwin, and that's how he was able to score 15. So now, if I ask the questions to all of you that how Sachin was able to do that kind of prediction, or Sachin was able to do that variation of R. Ashwin, what was the reason behind that? Anyone? Any thoughts behind this? You can put your thoughts in the chat. You can mention in normal English, not it should not be very technical, but yes, if you, or you want to tell also, you can unmute yourself and you can say the reason behind that. Okay, no worries. Now, there is another thought. Sachin is a genius because every prediction he made was correct. And second, Sachin's every prediction was right because Sachin is a genius. So, how many of you are agreeing with statement one? They can put one in the chat. And if you are agreeing with statement two, you can put two in the chat. And if you don't agree with any statement, you can simply put zero. Can we have some response in the chat? Okay, one. First, okay. Divesh, Harshada, okay, one. Can we have some more responses? One, okay. Oh, one. One. Everyone is saying one. Okay, great. Zero, okay. We got 1-0. One. One again, okay. One, okay. Sarthak is saying one. And Arjun, you are not agreeing with any statement, that's also fine. Okay. Vedant is saying one, Pranav is saying one. Okay, great. Mohit is saying one, great. Snehal, Somnath, one, okay. That's fine. One, yeah. So almost all are agreeing with the statement one. That's fine. You are agreeing with statement one or two, that's perfectly fine. If you're not agreeing with any statement, that's also perfectly fine. But the thought is that how Sachin was able to do that. So Sachin was having more than 20 years of international, national, and the domestic cricket experience. He played against different teams. He was playing in international matches. He has observed so many players. He played with R. Ashwin, and he had played on different grounds in different conditions. He played more than 400 international one-day matches, around 200 test matches. So he was able to understand that how the things are working on the ground when someone is having some bowler is having a particular setup for a fielding, then what kind of next ball he can do, or if some batsman is under pressure and he has to chase particular score, or he's looking for some kind of target to score, then what kind of thought process he will have and how will be playing that. So that kind of experience was Sachin having, and based on that, Sachin tried to put in a very effective manner, and he was able to predict that what kind of next delivery Sachin is, R. Ashwin can do that. Now, Sachin has collected all those information with his eyes, with his readings, with his training with the coaches which he had, with the experience he got in playing different matches. And he was having, obviously, Sachin is god of cricket, so he was having a lots of compute power. He was able to store that information in his mind and in his subconscious mind, and whenever it was required, he was able to produce some result and he was able to do the prediction. Now, the same thing, if I will give you the devices, it may be a camera, it may be a reader, it may be voice recorder, where you can collect all those information, similar kind of information or similar kind of matches which Sachin was able to play. And if I will give you the infinite storage as well as compute power, then would you be able to create a system? I'm just asking a question that would you be able to create a system which is artificial system and can do prediction like Sachin? Whether it will be 100% accurate or not, that's a secondary point. or how that can be created, it's another point. But just I wanted to understand your thoughts that whether we can create such kind of system which can do the prediction like Sachin was doing. If you are agreeing with this statement, you can put yes in the chat, or if you can put no in the chat. Yes. Okay. Siddhi is saying yes. Pranav is saying yes. Okay. Yes. 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 Yeah. Okay. We got almost all responses. Responses as a yes. Yeah. Thank you. So yes, we can create that system, which is going to be the artificial system, and that can predict the variation like Sachin was doing. So he can understand R. Ashwin's action, and he can also predict the next ball delivery to the batsman, that what kind of variation R. Ashwin is going to do. And he can also do some suggestion for R. Ashwin, because R. Ashwin and Sachin are playing from the India only. So they can also do some suggestion, because Sachin can also do some suggestions to R. Ashwin how he should improve his bowling. So if your artificial intelligence system is able to do that, or if your artificial system is able to do that kind of prediction, then that system is called artificial intelligence system. So welcome to the world of AI. And this image is also generated by AI, and you can see there is a mistake in the AI, this image, which is the spelling of welcome is wrong itself. I did not remove it purposely, but just wanted to show you that they're kind. It's not every time 100% perfect every time. So this is my good evening again. This is my introduction. Whatever the pictorial representation, whatever introduction Ashada has given, this is a pictorial representation of that. And without any further delay, let's go to some certifications which I had acquired after completing my engineering degree and when I joined my professional, when I started my professional journey. So these are the some certifications. These are the global certifications. These are provided by the original equipment manufacturer OEMs. For example, Microsoft has invented or created the Azure technology. So they have taken my test, and then based on that, when I got the required score, they provided me this kind of certification. So you can see the many certifications are there. You can also search for the AI certification, Gen AI certifications from different companies. And the best part of these certifications are these are globally recognized. So you don't need to worry about that from which uh, institute you have been passed out, what number of years of experience you have, what is your branch of engineering, it may be civil, mechanical, whatever. But the moment you will pass these exams, you will get these certifications, and these are globally recognized. It will have only your passing date, for how much duration the certification is valid, and your name with the signature of top authority. Sometimes it's a CEO also, and it establish your credential that whatever required skill set are there to recognize as a professional in that particular technology you are having that. And this also gives you a great opportunity to uh, get the job also in the market. And if you are learning something and you want to build your credential, as well as you want to learn something which is very much in depth in that particular technology, then these certifications and learnings are very helpful. And when you are appearing in the exams, it's not only going to be theoretical exam, it's a scenario based exam. So your hands-on skills are also tested for these kind of in this kind of examination. Now, coming to the formal definition of artificial intelligence, machine learning, and deep learning, artificial intelligence is whenever it's science that enables computers to mimic human intelligence. So, if we are creating any system, artificial system, which is capable of doing work that requires human intelligence, then that system is called as an artificial intelligence system. So artificial intelligence systems are not those systems which requires intelligence to build the system. When we are talking about the artificial intelligence system, so these are the systems which are the systems which can do the task which requires intelligence equivalent to a human to complete that task. So for example, there are many software programs which require a very lengthy program which requires a lot of intelligence to build or write that software, but those are not categorized as an artificial intelligence system because they are not having the capability to do the task which requires intelligence like a human. And what is machine learning? Machine learning is the subset which is something where you learn by the experience. So whatever data you are having, you will just uh, provide that data to your algorithm or the system and it will start learning. You don't need to write anything explicitly. You have to just select the algorithm and then you need to assign the data set so that your system can learn with that. And deep learning is a very specific field of machine learning that's uh, dealing with the artificial neural network. And whenever you are having any system or the software which has artificial neural networks, then it is called as a deep learning. And this is the relationship. Deep learning is a subset of machine learning. Machine learning is a subset of artificial intelligence. And AI you can categorize in two groups. One is the analytical AI, where you are having machine learning or the prediction. You have lot of data and you want to identify some kind of trend or you want to do some kind of prediction. Then that becomes your analytical AI. Computer vision, if you have some kind of images and you are uploading that image into your system and then it is generating a description of the image or it is generating a caption for the image, then it becomes the computer vision. Natural language processing, where your system is able to understand natural language statements and it is able to draw some kind of conclusion or inferences, then it is called as a natural language. Organizations are having large amount of data and based on that, they are trying to identify the customer behavior. That also requires a lot of human intelligence. So if your system is capable of doing that kind of work, then it becomes the knowledge mining. Anomaly detection, very simple example is fraud detection, where something which is not behaving as per its normal behavior. For example, you are trying to do some credit card transaction, which is very uh, near to your credit card limit, and then you are getting call from your bank that sir, you are going to do the transaction which is 100% of credit limit. Are you doing that transaction or not? So that kind of behavior, whenever you are doing that, comes under the anomaly detection, and it is very helpful in scenario where we are having a fraud detection kind of use case. For example, another example, you have done one transaction on your debit card in Mumbai, and after 15 minutes, there is another transaction someone has attempted from Delhi. So it is not possible as of now with the current technologies for someone to travel from Mumbai to Delhi in 15 minutes. So system will identify that this is not a normal behavior and that transaction will be blocked. So in this manner, you can do the fraud detection as well. So if your systems are able to do that, these kind of things, that becomes the part of analytical AI. And now coming to the generative AI, if your system is able to generate any kind of artwork, sound, images, video, text that does not exist, then that system is classified under generative AI. And if we are talking about the generative AI, so generative AI is the part of deep learning. Deep learning is the part of machine learning, and machine learning is a subset of artificial intelligence. So again, coming to our cricket example, if our Ashwin is having 20 kind of variations, and there is a batsman doing batting, for example, Richard Levy, and Sachin is coming and saying to Richard Levy, boss, out of those 20 variations, R. Ashwin is going to deliver you the 11th variation. Here, your Sachin was able to see the field and he was able to identify the situation, and then he predicted one of the existing data, which is out of those 20 variations to the to the batsman. So it's kind of the analysis where you are just not doing you are not going to generate anything, but you are doing the analysis on the existing data and you are predicting out of same outcome. So that becomes your analytical layer. Suggest new ball delivery for Ashwin. So Sachin and R. Ashwin are also played together for the India. If R. Ashwin is having 20 variation and none of those are getting effective against the batsman, so Sachin will come to R. Ashwin. You might have seen in the cricket matches when captain is coming in crucial overs to the bowler and then they are guiding something and they are suggesting something to the bowler in the same manner. If Sachin is saying, hello, Ashwin, you should try something different out of in addition to those 20 variations. So here you are going to create some kind of new variation for R. Ashwin, then if your system is capable of doing that, then it becomes the generative AI. If your system is analyzing all the news article provided by the user and it describes new ball delivery using text. So it is describing everything in a text. So input is text, output is text. Then your system is called as a single modal Gen AI. If your system is analyzing all the news article, images, video, sounds provided by user and create a video, it can be combination of video, image, or text, or it can be a different kind of input and a different kind of output describing the new ball delivery for RSN, then it becomes the multimodal Gen AI. And at the end, if your system is analyzing all the news article and it is collecting data from different sources like websites or the news article in an autonomous way, and it is able to create a working simulation model in the web application or the desktop application or any kind of program. So here it is able to take some kind of actions that is considered as a part of agentic AI. So these are the some mapping for the layman terms, or you can say very simple terms of the cricket and categorization of different kind of artificial intelligence on a single page. Now, in today's session, we will see some how and why for this AI, starting from the basics to agentic AI, and we will try to decode this black box, and we will see that how we can utilize this for the solving of the different problems in the real world. What are the different use cases, as well as how we can plan if we are going to work on a very critical project which is AI driven. So how before that we should understand how Gen AI will change our internet interaction with the world, and it has already changed so much. So earlier we had some interfaces which were computer interfaces which were text driven. For example, your command prompt where you are writing all the input as a text and you are getting output as a text, and you need to mug up everything so perfectly that you cannot be wrong in any command. If you miss any space or something here and there or some spelling mistake, then you are not getting the right answer. Then now we have current systems, very much current system, which are current UI based system where I'm presenting on the screen and you can see I have a mouse, I can do right click, left click, I can select chat box, I can select share screen, etc., etc. So this is graphical user interface kind of system. And with the help of Gen AI, we can communicate with technology like we are talking to each other in a natural language or with the help of gestures or the postures, whatever we are saying to each other. In the same manner, you can also communicate with the system which are Gen AI enabled. For example, you are writing natural language command and you are uh, creating a program, you are connecting to your database, and then you are writing instead of SQL query, you are writing a natural language command and you are taking the you are getting the output. So in the same manner, you will be able to communicate with all your databases or the software program. You can also you are also communicating with Siri and other Google Assistant, which is installed on your mobile phone, where you are just talking in natural language. You are giving the command, and they are able to take action and provide output to you. So why Gen AI is possible now? Because we have a large data set in a digital format, and that's why this is possible to have the Gen AI. We have pre-trained state-of-the-art model. There are many models like GPT, Llama, Gemini, which are available, and because of that, we have. And very interesting part, we have AI concepts available in theory since 1940s and 50s, but because of the lack of computational powers which requires for the AI or Gen AI, we are not able to build those systems. So GPUs, cloud, open source software played a very crucial role in the creation of AI and the Gen AI. Then some deep learning model which are very innovative. So we had generative adversarial networks, which is used for the image generation. Transformer architecture, we will see in little more detail. Reinforcement learning from the human feedback. So this is also very important. How your system will learn, and you cannot transfer every learning with the help of systems. Only sometimes human interaction with the system also is very important so that your system can learn. Now coming to the machine learning approaches. So there are majorly two machine learning approaches. Where we have historic data or we don't have any historic data. So if we have historic data, then we can have supervised learning where we use labeled data, and unsupervised learning where the data is not labeled. And In supervised learning also, we can have two kind of problem, which is again one of the classification and second is the regression. So for example, you have number of years of experience and the salary categorized below 40,000 and above 40,000. So the black rows you are seeing, if you have that data and you on the basis of that, if your system has learned and it is asked to predict whether person having 1.7 years experience will have salary less than 40K or greater than 40K, then that kind of problem comes under the classification. And here you will have label for the data. So X is your independent variable and Y is your dependent variable. Similarly, in the regression, here you don't classify anything. You don't have classes or category. Here exactly you are going to predict what exact amount of salary that fellow will get. So you will have data in the black rows and 1.7. If someone is having 1.7 years of experience, that what exact amount of salary he will get. So that prediction, if your system is able to do, that becomes the regression. And another is the unsupervised learning, where you will have all the data as independent variable. There will be no label or dependent variable. Here you will have number of years of experience as well as salary, and you will try to make a cluster or try to identify the pattern. For example, someone who is having less number of years of experience and high salary is a very good fit for the premium products because he is getting a very high salary so that he can he is earning the salary so that he can pay the high amount for that premium product, as well as he is having less number of experience. So generally that kind of people are having less liabilities also. So he is very comfortable with spending the good amount of he's he's very comfortable with paying good amount good price for a premium product. So for that kind of people, you can target with the help of this for premium products. Then another thing is reinforcement learning. It's not necessary that every time you will have historic data. So in that scenario, there are many algorithms. For example, Thompson sampling is one algorithm, and you will write that algorithm based on your use case. Now your system will predict something which is definitely going to be probability based. It will predict some or it will predict some outcome, and the human will interact in the real time, and then they will either select it or they will reject it. So if they are selecting it, it means they are rewarding the output is correct. And if they are rejecting it, it means the output is not correct. And in that manner, the algorithm will optimize that will learn, and next time when it will generate the output, it will have some kind of learning and it will try to generate a better output that will be more suitable for the user. So uh, if you have historical data, it's very simple. First learn and then play. If you don't have any historical data, then let's play, improve, and learn. And sometimes we are getting confused with machine learning and the statistics because again in statistics also we are having the historic data. But the challenge is when we are having statistics, there we have a population or the large amount of data, we are deriving a sample from that. So we will have a smaller sample, we will analyze that sample with the different statistical technique, and then whatever result we are getting, we are applying that result or inferences on the population or a larger data set. But the challenge is here, not every time the small sample or the smaller uh, data set is exact replica or the having exact characteristic of the larger or the population data. So in that scenario, it's not giving the appropriate results. So in the machine learning, whatever data you have, you are not going to create any kind of sample. You are providing all the historical data for the learning to your system. So that's how it is able to generate uh, more comprehensive, more customized results, and more accurate to the near to the requirement. Now, this we have seen about the structured data, but if we have unstructured data like natural language, then what is the challenge in that? So we will see some characteristic which of the natural language, and we'll try to understand how that has been incorporated in the different models so that we have this Gen I capability. So now there is a statement, I am a Vimal, I am an engineer, I volunteer for IET Mumbai local network. We can have rows and columns, and we can have numbers where we can have mathematical representation and we can create some equations. But this is a statement. Here I and M are not related with each other. Now, how should we represent this so that my system will be able to understand this natural language? because computers can understand only numbers and they are not able to understand natural language. So what is the way to do that? So tokenization is a technique where each word is going to be represented with the help of some numbers. So for example, will represent with 1. So this is for simplicity I am taking the example, but the larger model like Gemini or the GPT are having their own tokenization system and they are having very large numbers there. So for example, I is new word for me. I will assign 1 to it. Am is another word. I will assign 2 to it. Vimal, I will represent by 3. Again, I encountered I, so I will have 1 because I already assigned 1 in the past for the I. Am is another word which already encountered and I assigned 2 to it, so I will represent it by 2. And is another new word for me, so I will increment counter it. I will assign 4 to it. Engineer is the new word. I will assign 5 to it. To it. I already encountered, so I will use that. 1 volunteer is new word. 6 for 7, IET 8, Mumbai 9, and LN 10. So in this manner, I can represent all the words into the number, and then I can create simply a vector for this. So I and Vimal can be represented by a vector. So 1, 2, 3 will be the part of that vector. So in the same fashion, I can have I am an engineer and I can create a vector for I 1, 2, 4, 5. And I volunteer for IIT Mumbai local networks. This can also be represented by a vector where I will put bases here. For example, I will create I will create like this. So this will become my representation of I volunteer for IIT Mumbai local network. So this technique is called tokenization. And then this mathematical representation is provided as an input to the computer system. And then the computer system is doing some vector multiplication inside the model. And then as the output also, the same kind of vectors are produced. And then the reverse of tokenization happens because we already have the mapping of this 1 with I. So if I get I 1 as an output, then it will be reverse map and then I will be represented instead of 1. So in this manner, the uh, natural language has been is represented in the number form to the computers, and the same is done while we are getting the output in the natural language. Now, second challenge is this, that again, if we are able to assign some numbers to the words, the challenge is the meaning of the word changes as per the context. So here you can see two statements. I am going to bank to deposit money. We sat on the river bank. So here bank is same word used in two statements, but it is having a different meaning in both the statements. Second, I read newspaper every day and I read a book yesterday. Here, the spelling is same, the word is same, but based on the context like yesterday and every day, the meaning of the verb has been changed. So context is also important along with the natural language. Now, coming to the another piece, I had a productive day. I completed my task before time. If Rajesh is your friend and he is saying these two statements to you, how will you reply? Can you put in the chat? Hello? Yeah. Can someone respond that if Rajesh is your friend or any of your friend is saying that I had a productive day today, I completed my task before time, how will you respond to that friend? Anything, it's not necessarily technical. Whatever you will feel, how will you respond to Rajesh or your friend? Okay, no problem. Perfect. Prajna is saying okay, no problem. Can we have some more responses? Oh, great. Okay. Can we have a couple of more responses? I appreciate him. Perfect. Raj is saying amazing. Ashwat, good to know Rajesh. Okay, good. Perfect. Okay. Now, if Rajesh is saying this, I had a productive productive day today. I completed my task before time. I also got a promotion today at work. Now the first two statements are same, and he also added another statement. Now, how will you respond? Congratulations. Okay. Amazing. Okay. Congrats, Rajesh. So happy for you. Perfect. Happy for you. Yes. Amazing. Right. Great work. Happy for you. Congratulations. Congratulations. Congrats. It's a great news. Okay. Your day was really good. Perfect. Wow. That's really great news. Congratulations. Yes. So here, even though the first two statements were same earlier also, but now your response was more, uh, more after your response has been changed considering the last statement. So how it works? First, you focused on the productive day completed and before time. But when he told about the promotion, then you more focused on the promotion instead of the other words. So, in same manner, we need to understand that my system will also work in the same manner. How we are understanding in the same manner, my computer system should also understand so that he will be able to generate the responses like a human. So this mechanism is called as a self-attention mechanism. So attention is a way of giving priority to certain words. It extracts information from the whole sequence and it's a weighted sum of all the past encoded states. So there is a mathematical way to calculate the calculate the self-attention for each and every word. And it can be done in a mathematical way with the help of calculation of weighted sum. Now, this is what attention is all you need. The research paper, which was published in 2017 by Google, and this is the backbone of all the transformers. So whatever transformers, LLM models or ChatGPT we are using, those all are having the self-attention mechanism. So previous to this also, we were able to predict next sequence for the word, next sequence for the sentences, next sequence for the paragraph. But because of this self-attention capability, what was introduced in 2017, we had the foundation for the ChatGPT or other LLM models. So that the model which had this capability for self-attention capability, that was called as a transformer model. And now that was from text to text. If you have everything in the text, how will you generate the sequence? But if you have other modality, for example, along with the text, you have images or you have sound also, then in that case, how you will do the how your system will understand how you will do the prediction or you will generate the output in the natural language form. Then the cross attention is another technique which is used for that, where you will divide all the text into the chunks and then you will have a numerical representation, and then whatever images or sound you have, you will divide into chunks and then you will have mathematical representation for that, and then you will try to have the relationship between them, and that's called as a what word refers to the which object. And this is also another research paper which is available on the internet, and you can go and you can see. So you can simply type cross attention research paper or self attention research paper. You will simply go to these links. You can go and understand in more depth how the things are working behind the scene in any Gen AI model. And now coming to this, uh, after this, we understood that how we can represent our natural language representation or the images or the unstructured data into the mathematical form, and then we can utilize that for computation, and the system will do the processing and it will generate the output. But who will do that actually? So the artificial neural networks are very important, which are the backbone of uh, all the generative AI or deep learning models. In the artificial neural networks, you will have input layer, then you will have another output layer, and in between those layers, you will have hidden layers. So there are three types of layers: input layer and output layer, and in between hidden layers are there. There will be n numbers of hidden layer and n numbers of these circles which you are seeing. It is artificial neurons. So you can have n numbers of neurons in a particular layer, and then it will generate the output for you. But here is a catch. You will be able to see what is happening on the input layer. You will be able to see what is happening on the output layer because you will receive output there, but you will not be able to understand what exactly happening between or inside the hidden layer. And that's why these layers are called as a hidden layer. Now, this is the artificial neural network, artificial neuron structure where you will have input, then you will have some weights and biases. So this is again a mathematical representation where you will have weights and biases, and then you will have activation function, and then it will generate some output. So how it's done mathematically, it's a summation of input into the weights plus biases. So for example, for simplicity, if I have 0.5 assigned to my weight 0, minus 1 to my weight 1, so 20 multiplied by 0.5 become 10, 5 into minus 1 become minus 5. Now this will become 10 plus minus 5, 5, and plus 6, it will become 11. And if you have activation function, it says if my calculation or summation is greater than 10, you should represent it as a 1, or if it is less than 10, you can represent it as a 0. So this is for the simplicity, but there are many activation functions, for example, sigmoid, tan h, etc., which are able to generate different output within range or within a range, for example, 0 to 1, minus 1 to 1, or from minus infinity to infinity, 0 to infinity. So whatever requirement is there, based on that, we can select activation function. Now, why it is important? Because these weights and biases are called as a parameter. So whenever I am describing size of any LLM model, then these weights and biases are going to become very important. And when I am saying that there are 7 billion parameter in my model, it means there are 7 billion weights and biases in my model. So this is very basic LLM diagram. Every LLM will follow this kind of basic diagram where uh, uh, LLM stands for the large language model. GPT stands for the generative pre-trained transformer. And there you will have a block as an input layer. For example, in Chat GPT, you are putting your prompt on the in the chat, and then there will be embedding layer. So again, some mathematical information will be added to your prompt, and then there will be transformer encoder which will represent entire input into the mathematical form. Then matrix calculation will happen, and then there will be transformer decoder which will convert the mathematical output into the natural language or the image or the sound, and you will receive that on the output layer. So this is very basic block diagram. More or less every LLM, it may be Gemini, it may be Grok, or whatever model is there, it follows the same thing. It has same kind of a block diagram behind the scene. Then again, this was for the single model, for example, text to text. Now coming to the multimodal transformer. So there are many which can, like GPT-4o and others. So you can provide text as a input, you can provide image as an input, you can provide document, PDF files, you can provide audio or the video, and it can generate the same kind of or mixture of the combination of the two different formats. So it can be text, images, audio, or the video. There are some examples like OpenAI Clip, DeepMind Flamingo, Google Pally. These are the some example of the multimodal transformer. This is the cross attention mechanism which I discussed earlier, how it's working in the multimodal transformer. So text will be converted by the text encoder, then images will be converted by the image vision encoder, and then the cross attention will take care of these, and then the joint representation happens, and then it is provided to the multimodal transformer, and then the further processing happens and the output is generated. How to compute it? We understood that who is responsible, like transformer, neural networks, etc. But how to do that? So we have, for LLMs, we have pre-training, fine-tuning, and prompting. So we generally, whatever models are there, which are large model created by the original equipment manufacturer, for example, Google or OpenAI, how that model will understand the language. So first they are developing language understanding skills where we are providing lots of documents so that it can understand particular language, structure of the language, how the sentences, semantics are working, how the sentences are formed, how semantics of the languages are working. So that becomes the part of pre-training. Then once it is able to understand the language, then we are fine-tuning that model on a particular domain. And then in that scenario, we are providing very domain specific information. For example, from class first to 10th, you are learning everything. Then after 10th, in 11th, 12th, you are selecting a particular field like science or the arts or the commerce. And then you are going in engineering. Again, you are redefining your domain and you are selecting a particular branch of engineering. So in the same manner, in pre-training, everything is provided to model so that it can understand the language. And then in the second fine tuning, it is going to understand the domain specific knowledge. So pre-training and fine tuning is the technique where the weights and biases are going to change. But in the prompting, it is not going to change. Prompting is simply in which you are going to just give the instructions how to perform a particular task, and it will generate you the output. So if I will compare it with my cricket analogy. As a player, if someone wants to become a good cricketer, first he has to learn basics of the cricket, rules of cricket, all the rules. Then he has to achieve a good physique, good physical strength, and then he will try to learn either he wants to become a wicket keeper or a bowler or a batter or all rounder. So depending upon that, the fine tuning phase will be there where he will focus on a particular skill, and then he will go and play in the match where captain will provide instruction whether you are going to do bowling in first over or the last over, or you are going to batting on the first. You are going to open the inning, or you are going to do the batting on the third or fourth number. So that kind of instruction captain will provide in the match. That is simply called as a prompting. So there are some examples like zero shot versus few shot in transformer. So in prompting also, you can simply give a prompt like translate to French. So you are giving the word and you are giving the instruction. So the model will generate the output in the French. And sometimes you are not having exact instructions. So you can simply give some examples. For example, here I am giving English cat and then chat, then dog, Chien. So now what will be house? So my model will understand that first two examples, the first words were English and the later it was generated, the word were French output. So he will convert the house into the mason. So this is something uh, very simple example of few shot learning where in prompting, where instead of giving direct instructions, clear instruction, you are going to give some examples and your model will be able to understand. So pre-training, fine-tuning and prompting. Pre-training and fine-tuning are very costly. It requires a lot of efforts, lot of resources. And the challenge is that it requires a lot of time also. So it will not be able to help you with the live data. So there is another architecture which is called as RAG, Retrieval Augmentation Generation, in which you will have all your live data in a particular database, and you can use a pre-trained model or fine-tuned model which will connect to RAG, which will connect to your live database, and then it will answer to you. So this is a very simple example where you can have a different kind of requirement, and based on that requirement, you can select whether you need to pre-train your model or fine-tune, or prompting is something which can be which will be sufficient for you. So prompting, generally, whatever AI use cases or AI work is happening, 70% time we are doing prompting, 20%, 25% time we are doing fine tuning, and very less 5%, which is done by the original companies. They are doing the pre-training. And these are some common LLM models. This is little old list, but again, just I have given for the simplicity and representation, where you can see their model parameter size, number of parameters. So Falcon is having 7 billion to 40 billion parameter, MPT is 7 billion, Dolly is 12 billion. So whenever I am saying this number, it means the number of parameters, it means the weights and biases in that particular model are these many particular weights and biases are there, and it defines the size of a model. We can have open source model which you can train on your data, but there are closed source or proprietary model like Gemini or the Chat GPT, which you cannot train or fine tune. You have to do only prompting with that, and you can get the output. And it's very compute intensive task. So the GPT-3 model with 175 billion parameter trained on 300 billion tokens. So we are we have seen what is the meaning of tokens, and again, whatever price you are going to pay for the AI models or Gen AI models, it's based on the tokens only. Whatever number of input tokens you are going to provide and how many tokens it will generate in the output, based on that charging happens. And it cost around $12 million in just compute for the GPT-3 model. Now we have GPT 5.1. So just try to understand how much compute and how much cost it will require. And this is the training compute requirement in petaflops over the year for all the transformer as well as the LLM models which are there. So again, having a entire picture in a single slide. So you will have pre-training of your data, you will have supervised learning. So this is for Llama 2, and then you will fine tune your model. And then even though you do the supervised learning and supervised learning and you provide all the data, but still it will not be able to generate output every time, which is very similar to human output. So reinforcement learning with human feedback is also very important. And ChatGPT, once it was created, it has been given to thousands of people where ChatGPT was responding and they were providing the feedback on those responses. So nowadays also, if you working with the ChatGPT, when sometimes it is giving you the two responses and it asks you whatever is the preferred response by you. So that is example of reinforcement human feedback, reinforcement learning with the human feedback, and then that model is deployed in the production. So this is the one example where you can see end-to-end model training and all the things which we have learned till now. And all models are having same capability. The answer is no. So there are LLM benchmark. You can go and simply check on the internet. So before you select any particular LLM for your use case or whatever LLM you have created, whether it's working on it's suitable for which kind of use case, there are LLM standard benchmarking where they have a standard data set. You can provide that data set as input and then the output will be generated, and based on that the scoring is done. For example, MMLU, it's multi-language understanding. So a Llama 2, 7 billion is getting 45.3 score, but Llama 1 with 65 billion is having 63.4 score on that. It means Llama 1 65 billion is better for the multi-language task in comparison of Llama 2 7 billion. So in the same manner, you can see we have capabilities, different capabilities of the benchmarking in this column. And on the rows, you will have the score for the different models, which you can see. Higher the number, higher the score is, greater the capability in that particular benchmarking. And again, there is another choice where whether you should have a single large LLM model or you should have multiple small LLM models. So there are factors on the basis of which you are going to select. So it may be performance, it may be cost, scalability, flexibility, latency, because larger the model, it will respond, it will take time to respond. And sometimes, for example, you have a particular use case related to finance, then why should your model have knowledge about marketing? Because larger the model, large number of the parameters, it will take more time to generate the output. And if you are going to do some kind of fine tuning or the learning on top of that model, it will take more resources, more cost to fine tune that model. So these are the some factors which we need to consider. And if you have a single large LLM model, if it goes down, everything is a fail. And if you have a multiple small LLM models, which is represented behind one API, then you can select a particular model. You can respond for every query. There will be different model, and whatever queries are coming, it will filter on the API layer, and then whatever model is responsible for that, it will reply for that. And if one model goes down, your other models are still working, so you will not have 100% downtime with the failure of one model. So these are some limitations of the Gen AI. It may not be 100% accurate. It depends on large data set. It has ethical concern. It requires high computational cost, but again, it has a lack of interpretability, and it has smart decisions. It has a capability of content generation, but it does not have a ability to take action. So for that, agentic AI is in the picture, which is not only intelligence, but it has a capability to take action. And how agent are made AI agents. So it is simply LLM plus the reasoning plus external application and plus self-reflection capabilities. So whenever we want to create any AI agent, it will have LLM which can do the reasoning. It is connected to the external application, and based on the actions, it has a self-reflection capabilities, and based on that, it decides how should I perform that particular task or whatever goal has been assigned to me. It has a self-reflection capability, and it has its own understanding to perform that task. So very simple. If you have end user, you can query, and there is an agent runtime where the agent is going to run, and then it can connect to the external tools. It may be functions, APIs, and databases, and then it will generate its response, and you can connect it with the different Gen AI models, and you will have your agent running ready. This is Vertex AI agent. This is again a Google technology. If you are looking for some tools where you can do the agentic AI kind of experimentation, you can simply have Google Vertex AI and you can build your agent. They are like a software development kit. They are having agent development kit where you can create your own agent with different capabilities. And there is also agent garden where predefined or pre-configured agents are available. You can also use them, customize them, or you can create your own agent. This is another piece how the agents can interact with the external world. So the MCP protocol, which is launched by Anthropic last year, and agent-to-agent protocol is the another protocol, which is agentic AI protocols. Like we have HTTPS, FTP, STTP for communication on the web as well as for file transfer. In the same manner, agentic AI can interact with the different tools which are there externally with the help of MCP protocols. So Zomato has launched their MCP protocol, MCP server. Zerodha has launched their MCP server. So you can have you can have MCP server connection with Zomato, and you do not require to go and log into your Zomato application. You can simply chat on the LLM model, and it has a capability to connect with the Zomato, and it will order everything, whatever you want. It has all the capabilities from searching to ordering and doing the payment, and it will do it on the behalf of you. So this is very latest technology. If you are looking for some kind of research, you can also focus on these kind of things, which are peripheral external device optimization, security, etc., and the protocols which are required to run those kind of agentic AI models. AI is for us, so we should use AI responsibly. The fairness, it should not have any kind of biasness. Whatever AI system we are creating, it should be reliable and safe. It should respect privacy. It should not breach the data security and the privacy. It should be inclusive for all. It should be transparent. And if we have created any AI system and it is not doing as per the expectation, or it is doing some wrong work, then who is going to be responsible, who is going to be accountable for that? That accountability has to be also set up. So these are some principles of the responsible AI. And this is also a very good area of research, and a lot of work is happening here because still we are lacking for the governance in the AI domain. And you can work in that domain also if you are very much interested in the governance or the policy making. So now it will take another 10 minutes. I sincerely apologize for it, but I think I should cover these things so that it will complete your understanding related to AI. My sincere apology, but it will take another 10 minutes for that. So AI or cloud, because AI requires a lot of resources, high compute, memory, etc. It's not possible to have that kind of AI, enterprise AI model available on your system or the laptop. So you must require cloud for that. And that's why it's not AI or cloud, but AI plus cloud. And these are some concepts related to generative AI where you can have AI as a service. So everything will be available as a endpoint where you can have authentication and you can directly use those services. No need to create any model, no need to do any kind of training, and no need to take any kind of headache for the maintenance. These are examples of the services like Amazon SageMaker, Google AI Platform, Azure AI, where you can directly go and do subscribe, and you can use ready-made AI services for your task. You can directly integrate those in your application as well. LLM as a service, where you can have LLM on subscription basis. So Azure, Anthropic, Claude, they are providing the LLM as a service, which you can use on the basis of input token and output token will be charged. And you can simply integrate with the help of endpoint and authentication mechanism in your application. If you want to manage, if you don't have capability to manage your data as well, so that also can be done with the help of data as a service. So you need not to worry about that. You can have cloud based services where you can put all your data, you can do all the cleaning and management for your data. And this is also very popular. Snowflake, BigQuery, Databricks, Lakehouse are some examples of the data as a service which are very much popular, and they are having lots of capabilities. So now we talked about the generative AI cloud concepts. We should also talk about the data, because without data, nothing is possible. You cannot have the required capabilities in your AI if you don't have the required data. And for that, you need to do the processing of your data. So it was Hadoop, which was having the distributed parallel processing in the disk. So if you have 10 GB of data and you are doing sequential processing, and 1 GB requires 1 minute, so then it will take 10 minutes to process the 10 GB data. But if you are doing in parallel, then you can do 1 GB, you can create 10 fragmentation, and then you can process 1 GB data and 1 GB data in 1 minute, and you can have 10 parallel processing. So 10 GB data you can process in 1 minute, and you will save a lot of time on that processing. So Spark was something which was in memory distributed parallel processing, and then Databricks, which was in memory cloud first. So Spark was not having the capability of cloud, which was not having the scalability and reliability like a cloud. So Databricks is something which is in memory cloud first parallel processing. There are many systems similar to this also. This is how you will store your data. Earlier we had data warehouse where we could store structured data. Then data lake was there where we could store unstructured data. But at that time also we had a requirement of data warehouse, so that for structured data we were using the data warehouse, but unstructured data we were using data lake, and those two systems were running in parallel. But now this is again a new concept, data lake house, and it's open source. And again, if you are not very much interested in AI, but you want to work in a field of data, because IoT, if you are working in IoT domain, you will have a lot of data coming from the sensors, coming from the different systems. Then you should understand how you can process that data. So unstructured data and the structured data, both you can store and you can govern, you can process with the help of data lake house, and you can have a same layer of governance which can cater your services for the structured as well as unstructured data. So, and this is a medallion architecture where this is very much common, widely used in the AI or data industry, where you can have batch job or the streaming job. The data is coming continuously, then it's streaming data. Data is coming at regular interval. That's called as a batch data. For streaming, your IoT devices can send data. For in batches also, your IoT devices can send the data. So you will have three different layers. On bronze layer, you will save the data as it is raw data, and then you will have a silver layer where you will do some cleaning. You can eliminate, you can clean the data. You can put all the data in a single format for that particular column. And then at the gold layer, you will have a business level aggregation, and you can represent the data to your users. It can be utilized for machine learning. It can be utilized for business intelligence. It can be utilized for Gen AI. Whatever use cases you are having, you can utilize for that. And this is the data warehouse, which is Microsoft Azure services. So here you can see we have IoT devices, sensors, gadgets, which are sending the data. Then we can receive that data with the help of Event Hub, and then we can put that data for storage in the Azure data storage or in the database. We can also we can also do the live analysis of the data with the help of stream analytics job. Spark Pool, SQL serverless pipelines. This is again from the Azure Data Factory, Azure Synapse Services, Azure Machine Learning. So these are the ready-made services which are available in the Azure platform. Similar kind of services are available by different cloud service provider. It may be Google, it may be Amazon, it may be IBM, it may be Snowflake, Databricks. You can go and simply check that what is the similar kind of service which you have where I can use for my data warehouse or the pipeline or AI. And then at the end, you are going to put that data for consumers and you can use different tools. It may be web application, it may be orchestration engine like Logicast, it may be a function, it may be Power BI for analytics, it may be GenAI application or whatever you want. You can connect with your data platform and then you can utilize that data. So real world examples, you can have autonomous coding agent like we have GitHub Copilot where you write the things and it is able to generate code for you. You can have supply chain agents which can do material forecasting, vendor negotiation, inventory responsiveness. You can have healthcare agent teams. You can have robotics agent. So these are some examples of the agents which you can make from the industry perspective. And these are some industry use cases which are having very high impact from the Gen AI and agentic AI perspective. You can use autonomous monitoring agents reading sensor data in manufacturing and industry. You can have predictive maintenance, automated scheduling. You can have AI controlled supply chain negotiation. For energy and sustainability, you can have agents optimizing load balancing and microgrid control. You can have autonomous simulations exploring thousands of energy system configuration. You can have civil and infrastructure AI agents, which is AI side supervisors monitoring progress either via drone feeds. You can have automated compliance checking against building codes. You can have multi-agent traffic flow optimization. And you can use, like we discussed in computer science and IT, in healthcare and biomedical engineering. How will we be planning for the AI-driven engineering project? So it's very simple. You first define the problem clearly. You should frame why you need to solve that particular problem. Then you should break down that system, what system require, data layer, model layer, integration layer, then user layer. Then you should choose your AI strategy, how you will do pre-training or whether it's required or not, whether you require to do fine-tuning. Do you need agentic AI or not? What kind of LLMs you should use, and then based on that, you should create execution plan with the timelines and you should assign very clear roles. So great AI projects succeed not because of complexity, but because of clarity, structure, and feasibility. And if you want to do any kind of innovation, so there is a very simple framework for AI and the IoT projects. So you can have, you can look for the patterns, failures, inefficiency in the system. Then you should use data for thinking what can data reveal that humans cannot. Then you should connect the domain knowledge like mechanical, civil, electrical, computer science with AI capability. Then you should use the AI innovation triangle, problem, data, and intelligence layer, and then apply modern data architecture like we discussed, Mendelian architecture. Then add autonomy. You can have multi-step planning. You can use different tools like API, IoT devices, services monitoring. It is useful for the robotics, automation, manufacturing, and energy system. And what makes an award-winning student innovation solves a real problem with measurable impact, demonstrate clarity in design plus AI explainability. It should not be just that you have done something, but why your system is able to do that. Use responsible AI principles, fairness, transparency, safety, etc. Show a working prototype with data-backed results. So innovation comes understanding the problem deeply, using AI responsibly, and then integrating data and autonomous smartly. So again, I will not go in detail. So model development is not equal to software development. Often we are doing the real modeling, which when we put model in the production and we are going to rarely deploy the same model twice. How fast you can tune your model on customer data is more important than accuracy of model, and how fast depends much more on the problem than the algorithm. So sometimes the algorithm will not play the major role, but what kind of problem you are going to solve has more important role than your solution, than the algorithm you are going to use. And these are some examples like Azure is having the services. This is just for the reference purpose. If you want to go and explore, you can just go and explore. The links are given and you can understand more about the projects. These are also providing many learning materials, which is created by the Microsoft, Google, or the Amazon, as well as by OpenAI. They have their own academies where you can simply log in and you can get a lot of learning material from there. This is again example of the Vertex AI Studio by Google. This is Media Studio where you can create videos, audios, you can create agents. This is a picture just to show that you can have different kind of use cases and different kind of capabilities, which is readily available on the cloud platform. And now last last 5 slides and 5 learnings. So English is going to be the new programming language. There we don't require to learn. We don't require to have Python or that kind of programming language. You can do programming with the help of English also. It's not the revolution of AI, but it is the revolution of data. And your model, my data, your company, the company will provide the model, like different companies are doing, but you need to provide your data, then only it will be useful for your use case. And it is going to be data plus AI, not only AI. And it's not going to be only agents, but it will be human plus agent. With that, thank you so much. If you have any question or answer, I know I surpassed the limit of time, but I thought I should cover the entire thing. I will share this PPT and I hope you got something new, which you did not explore earlier. And this is my LinkedIn QR code. Please feel free to connect with me. If you have any doubt from this session, you can ask me over there also. I will be very happy to answer that. And again, once again, sincere apologies from my side for extending this session beyond stipulated time. Thank you, sir.
Which is fine, sir. You don't need to be sorry.
Yeah.
Sir, we are open to question and answers now. So anyone who is having any question and answer will quickly take some questions and sir will answer those questions.
I have one question. Do you think the growing use of AI is reducing people's critical thinking skills? Yeah, that's right. There is a recent study where they have already told that with the help of whatever AI we are using, it is impacting the intelligence of the humans. So you are correct. With AI doing more thinking for us, do you think human thinking skills could decline in the future, maybe even close to zero? It may happen. I'm not sure it will go close to zero because human has capability of evolution. So as of now, we are seeing some decline, but future I cannot say that it will go close to zero. But yes, definitely is going to impact. But as human has a capability of evolution, it may evolve itself and it may have some new capabilities. So you never know what is there in the future.
Any other questions from the participants?
I have one. Related to our question, when how to use AI, Sujit. So again, my thought is that whatever you can do without AI, you should do without AI. For example, 2 plus 2 you can do with your own, or even though there is some larger number, for example, 350 plus 475, you can use calculator, but you cannot. You should if you will talk to AI model, it will generate the output, but again for same kind of capability, it is taking a lot of electricity, lot of compute. So we need to think in that direction also. So whatever task is possible without AI, we should do that without AI. And wherever you feel that you cannot do without AI, then you should go with AI. Will prompting be in scope in future as a skill? It is currently there. And again, I want to provide update here. Some like Google is also providing that service. So Google Media, uh, Google Vertex AI, which I have shown you there, if you don't know how to do prompting, just write task and then click on the improve the prompt or write a prompt. So it will write a good prompt, which is suitable for the system, and you can store that prompt, or if you want, you can use that prompt in the future also. So prompting is already taken care by a lot of AI models, and it is also available as a service. So I don't think so. It will be last for a very long time as a skill in the future. Is it possible to make AI 100% unbiased like a perfect human? It's not, because humans itself are not human beings are not perfect as of now. So, and second thing is that whatever AI systems we are having, that is based on the data, and whatever data is generated, again, that is generated by the system or by the humans, and whatever biases we are having in that data, that is going to be reflected in the AI system as well. And many times, whatever data we are providing, it has that human biases, and that's why it's very difficult to make unbiased AI. You can put some guardrails, for example, uh, uh, if it is generating any harmful content, it should not produce that content. Now another piece is that LLM as a judge, which is also a capability where whatever the output is generated by AI model, you are evaluating that with the help of another
So
LLM. You can also create some kind of rules so that whatever output it is generating, if it is biased, it will not produce to the human. For example, if someone is asking for how to create a bomb, right, that information should not be available. So in the same manner, for the biasness also, you can create some rules and you can apply and enforce those rules on your model. Another thing is that what are the limitations of AI where it will not replace the human being? As of now, people are working on AGI, which is artificial general intelligence, but that is not used for the industry use cases. But talking about the current AI limitations, it is not able to think in a manner like we humans are thinking. So the kind of intuitions we are having, that is not available with will that is not available with the AI. And again, whatever AI models you are making, that is based on the data. So even 5-year-old baby, what kind of task he can do, if you want to do that kind of task with the help of AI model, you will require a lot of power, lot of data for that. So the way humans are thinking, that is not available with the AI as of now. So this is one answer. Ravin. Ashwat is asking, okay, where it will not replace the human being. In future, you never know, but because people are making the system or they are claiming that in very near future, we will have a system which will able to think like a human. So that's, you never know the future, but yeah, people are working in that direction. Ashwat is saying, in the near future, will AI affect engineers working in the core sector? Yes. How it will affect? Because now it has already impacted software engineers. It is writing code and it is uh, it without writing any without learning any Python or any Java, you can write a code. But the challenge is that whether that code is right or not, who will evaluate? So humans are required to evaluate that code to check that whether this code is correct or not. So that is there. And for the core branches, like I told that agentic AI is there, so it is the software, but in the very near future there will be robotics, which is going to be changed, and AI system will become so intelligent that it can create robots also. So definitely it is going to change the core branches as well. Uh, Sir, can the AI model learn patterns like human behavior or object path? Yes, it can learn the patterns, and that's how AI is developed. Is there any AI that can train other AI for specific tasks like playing chess? Yes, it is there. Will AI increase unemployment? Yes. How will AI change the types of jobs available in next 5 years? See, recently Elon Musk has said that after 2 decades, around 20 years, after 20 years, doing a job will become very optional because everything will be done by the AI or the autonomous system. And secondly, the creator of LinkedIn or the founder of LinkedIn also said that after 15 years, 10, 15 years, everything will become so cheap that we don't need to work. So if everything is done by the robots and the artificial system or uh, 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 the artificial intelligence system or the robots, then that are very much scalable. So you can just replicate that, and they don't require any kind of salary. And there's autonomous robots can do so much production that it will be sufficient for the humans, and they can use that things. It may be personal things, whatever food, whatever houses you require, everything can be created with the help of robots, and that can be distributed to everyone. So there will be no need to do the work. So everything will become so cheap. And increase now here the definition of unemployment is also important. Uh, like AI will make job optional for you, working optional for you. So it depends whether you want to do the if someone is if job is available, but if someone is not willing to do the job, then it is not considered as unemployment. So this is something which is very important. So it will depend upon our behavior also. If we were not willing to do the job, then there will be no unemployment. But if yes, we are going to look for some kind of job and that is already done by the AI, then definitely unemployment will be there.
We will take only one question now, and then we will stop because we
Sure.
are. Yeah.
Yeah.
Rest of the questions I will forward to you. Maybe you can answer to that.
Sure, sir. Will AI totally replace engineers working in core branches? Yes, it will. If AI affect the core branches, then I am mechanically, how should I evolve myself? Okay. These are very important questions and all are related to employment. Mechanically, how should I evolve myself? As far as for now, for the mechanical engineering, you can focus on the core concept. Still, the robotics has been not evolved in that way that it will create entire building by its own. So creativity is something which is very important, and having the fundamentals clear is another piece which is very important, because all the AI models are as of now are the probabilistic model. So there are chances that it will create an error. So you should have that kind of knowledge where you can have some creativity, as well as you can evaluate all the outputs by the AI models on the fundamentals. So if something violating fundamental, then you should correct that. Yes, sir.
Okay, sir. Thank you so much for answering all the questions that our participants have put in the chat box, and the remaining ones you can answer it laterwards. So,
Yeah.
coming towards the end, thank you so much, sir. That was an absolutely insightful and eye-opening session. I'm sure everyone here gained something meaningful, whether it was a new perspective. I'm sure every practical workflow knowledge or fresh inspiration to explore AI and IoT in their own projects. To all our participants, thank you so much for being here, an enthusiastic audience. Just a quick reminder, certificates will be provided to all the registered attendees who have attended for more than 45 minutes. Also, the IET KK.WAGH Expo screening round is now open. You can submit your projects through the official link, which will be shared via email and is already available on our LinkedIn and Instagram handles. Follow us today and stay updated. We are also launching a hands on project making workshop in the first week of January, featuring experts from various domains to guide you in developing your project effectively. This 1 day workshop will run in 3 sessions in both online and offline modes. Stay tuned for more details. A big shout out to the IET KK.WAGH Expo Organizing Committee, carrying forward a 23-year-old legacy of technical excellence and youth driven innovation. Thank you everyone for joining in and have a great evening ahead. Thank you so much, Vimal Chaubey, sir.
Thank you. Thank you, sir.
Yeah, thank you. Bye. Good night.
Bye. Good night, sir.